Welcome to the channel. Today in this tutorial, let's write a Python program to print a number in Fibonacci series using recursion. The Fibonacci sequence is a series of numbers where each number is the sum of the two preceding ones, usually starting from 0 and 1. Okay, it is a series of numbers starting from 0 and 1. We know first two numbers, and to calculate the next number in the series, we need to add previous two numbers 0 plus 1, so we'll get 1. This is the next number. To get the next number in the series, 1 plus 1, that is 2. Next, to get the next number, 2 plus 1, 3. Next, 3 plus 2, 5. 5 plus 3, 8. 8 plus 5, 13. 13 plus 8, 21. Like this. This is the series of numbers where each number is the sum of previous two numbers and the starting two numbers of this series is 0 and 1. It is the number at the 0th index in the Fibonacci series. This is the first element, second, third, fourth, fifth, sixth, seventh, eighth. In mathematical terms, the number at the nth position can be represented as f of n. So here we know f of 0, that is 0, and we know f of 1, that is 1. First two numbers of the series. We can represent them like this. And for the number in the nth position, we can write like this. n minus 1 plus f of n minus 2. Sum of two previous numbers. For example, if I want f of 2, that is actually 2 minus 1, 1 plus 2 minus 2, 0. F of 1 is 1 plus f of 0 is 0. So, value is 1. Here you can see. The number at the second position in this series is 1. Here, input of our program is n value and output is the Fibonacci number in the Fibonacci series in that position. For example, if n is equal to 2, the Fibonacci number in that series in the second position. So we can write the Fibonacci definition like this. Initial two numbers are 0 and 1, and for rest of numbers that is greater than 1, we can write f of n is equal to f of n minus 1 plus f of n minus 2. We need to add previous two numbers to get the next number in the series. Now, to solve this problem, we'll use this formula. For example, if I want to find f of 5, that is actually sum of f of 4 plus f of 3. But here problem is I don't know f of 4 and f of 3. What to do? To find f of 4, it is actually the sum of f of 3 plus f of 2, right? I'll use the same formula to find f of 4. Plus f of 3 is nothing but f of 2 plus f of 1. Sum of previous two numbers. Now, I don't know f of 3. F of 2 plus f of 1. For f of 2, it is actually f of 1 plus f of 0. We only know f of 0 and f of 1, the first two numbers in the series. And for f of 2, same, f of 1 plus f of 0 and f of 1. We know its value. Now for f of 2, it is actually f of 1 plus f of 0. I'll substitute value for this. F of 1 is 1, f of 1 is 1, f of 0 is 0, f of 1 is 1, f of 0 is 0, f of 1 is 1. Then here f of 1 is 1, f of 0 is 0. So f of 5 is 5. 0, 1, 2, 3, 4, 5. Yes. If I mention fifth number means the number at fifth index, okay? It will start from 0. I'll use this method to solve this problem. And to do this, I'll use recursion. So what I'll do is, I'll write a function, a recursive function, and I'll call f of 5 or Fibonacci 5. We want to find the output for this. To find f5, the function calls itself to find f4 first, then f3, f2, f1. For all this, function calls itself to find the values. After finding the value, it will add that and combine the result and it will give you the output. We'll call this function and rest of the function is called by the function itself. It will call itself to solve the smaller problems. So here we are using recursive approach. That means we need base case and recursive case. Here base case is, we know two values, right? When n is equal to 0 and when n is equal to 1, that is f of 1 is 1. These are the first two numbers of the series, right? These are my base case. And for recursive case, as I said, if I want to find the Fibonacci number at 5th index, I'll call this function. And to find this, first we need to know Fibonacci 4 and Fibonacci previous two numbers. And to calculate this, we need to know its previous two numbers. To calculate this, we need to know previous two numbers. Our function calls itself to calculate this. Okay, then let's write the program. In the IDLE, let's define the function. I'll take function name as Fibonacci and here n value. We want to find the Fibonacci numbers in this index, nth index in the Fibonacci series. First, let's write the base case. As I said, we have two base case. First one is if n is equal to 0, then return 0. If n is equal to 1, return 1. Then here recursive case, return function calls itself with n minus 1 plus n minus 2. Here we have two recursive calls. To get the next number in the series, we need to add previous two numbers, right? Let's take the input for n, an integer input. It is index actually. Okay, we are done. Let's save this and execute this. Fy is 5. Is 8. Now what if I want to print the whole series? For example, if n is mentioned 5, I want to print all the numbers till that index. Then how to do that? For that you need to use a loop here. You need to start from 0 and n plus 1. Then call this function and print this. Zeroth index, first, second, third, fourth, fifth, sixth, 7th, 8th, 9th and 10th index. Zeroth index, first index, second index. Okay, so this is about Fibonacci series. So that's it for now guys. Thank you for watching. Don't forget to subscribe to my channel. I'll meet you in next class. Till then, take care.